Have you ever wondered how a piece of fabric can slow down a fall? Can the weight subtended or the material of the canopy or the area of the canopy affect the descent of the parachute? Here are we investigating upon these factors using a handmade parachute. We will calculate the drag force and the drag coefficient. First, let us understand what do we mean by drag force and drag coefficient. What is drag force? When a body moves through a fluid, here air, it experiences a resistive force. This resistive force is opposite to its motion, and this force is nothing but the drag force. Now, what is drag coefficient? Drag coefficient is a dimensionless value which quantifies the drag force. We have investigated the drag force due to the change in radius as per 35, 30, 25, 20 and 15 cm. To calculate this drag force, we have used the formula half CD rho A V square. To calculate this drag force, velocity being 5 meter per second and drag coefficient being 1.2 are kept constant, while the area is kept as the variable factor.
As mentioned earlier, our variable factor is weight suspended. To calculate the drag force for each of one, we use the following formula. And by substituting the values, we get the drag force. Here we have taken rho as 1.225 kg per meter cube and velocity is kept constant, which is 5 meter per second. And the drag coefficient values are also assumed.
Same formula is used to calculate drag force with varying mass as 20, 40, 60 and 80 grams. The drag force is then calculated using the drag coefficient values as 1.2, 1.3, 1.4, 1.5 respectively.
So, to calculate the change in drag force due to the change in area of canopy, we use the formula Fd is equals to half CD rho A V square, where A, which is pi r square, the area of parachute's canopy, rho, the density of air, which is taken as 1.225 kg per meter cube. The assumed values are CD, which represents the drag coefficient, is equals to 1.2 and V, which is velocity, is equals to 5 meter per second. Likewise, we will calculate the drag force using different radius. The radius is equals to 35 centimeter is equals to 0.35 meters. The calculated area using the formula pi r square is equals to 0.3848 meter square. CD is equals to 1.2, V is 5 meter per second and rho is equals to 1.225 kg per meter cube. Using the formula mentioned above, we substitute the values as 1.2 into 1.225 multiplied by 0.3848 into 5 square whole divided by 2. By calculating this formula, we get the answer 7.09 Newton.
Next, we also know that different materials also affect the descent of parachute. Here we have used 4 different types of material: plastic, silk, polyester and cotton. To calculate the drag coefficient of each of the following, we use the formula CD is equals to 2Fg upon rho A V square.
Now we'll assume the terminal velocities of different materials. Polyester is equal to 5 meter per second, cotton is equal to 5.5 meter per second, silk is equal to 4.8 meter per second, plastic is equal to 4 meter per second. Now, using the formula of CD, first we'll calculate the CD. After substituting the values, we'll get CD as answer 0.306. Now that CD will substitute into the formula of FD. After substituting the values, we'll get FD is equal to 0.588 Newton. This is same that FD is equal to mg.